everybody. Welcome to the Sydney HashiCorp user group. This is our monthly meetup. At the moment, we're still doing it remotely, but we're really looking forward to having it in person to meet everyone soon. So this is actually the first one for Sydney, which is quite exciting. We're looking forward to a lot to come next year, and anyone can talk on these meetups as well. So it's completely open for the community. So if anyone ever wants to talk, anything HashiCorp, so whether it's, your experience using Terraform, study tips, HashiCorp file console, anything really infrastructure as code, please reach out to us, and we're more than happy to have you. So today with me, we have Ben. Ben is a cloud engineer at Moola. Thanks for coming to talk today, Ben. And he'll be going over Terraform. So we'll keep this sort of intermediate level, but if anyone has any deep dive questions, we're more than happy to answer them. So please keep it interactive, ask us as many questions as you want. And yeah, thanks, Ben. I'll leave it for you.
Great. Thanks, Brett. All right,
Maybe
so I'm just going to swap
if you just want to maybe give an introduction and a bit of your experience as well, please.
Yep. So my name is Ben. I'm a cloud engineer at Moola, as Brett had mentioned. Came from quite a different background. I used to work as an architect for physical buildings before deciding to transition into the software world. Got into cloud engineering. I've mostly done Azure specifically for cloud rather than AWS or GCP. But the benefit of what we're doing now, what I'm planning to show you in Terraform, is that it's quite cloud agnostic as a tool. It's very easy for you to transition from one provider to another. And this is going to be the demo that shows it how it works. Swap over to another screen now. All right, so this is the agenda for today. There'll be a quick demonstration of Terraform, IAC as a tool. So as I mentioned before, I've done mostly Azure, but this will show you the difference between using Azure Resource Manager against, say, AWS's CloudFormation and Terraform. And this is a quick demo for creating a storage container or an S3 bucket. Moving after that, we'll be talking about how we use Terraform, because Terraform itself, you can use it to deploy a single deployment, or you can make it as a template that enables you to deploy it cross-deployment in multiple environments, multiple scenarios. And then we'll be moving into modules, which is a slight increase in the intermediate level. So going from just deploying straight resources to reusable modules, and the benefits of using that against potentially some of the downsides. And the last step of all is how we automate deployments via pipelines. So let's start with the very first, the basic. It's sort of like a cooking show where I've got everything prepared in advance, and you'll see how it all works.
Can you just zoom in a bit as well, please, Ben?
Yep.
Sure thing. Yeah, that'd be awesome. Thank you.
So first one, this is creating a storage account in Azure. This is what is known as an ARM template, ARM standing for Azure Resource Manager or Management, one or the other. So to create a storage account in Azure, this is a pretty long machine-readable format JSON, but for a human-readable version, you kind of need to know where exactly to look to get to the goodies on how you're actually deploying something. So it's quite long, it's quite messy, not so easy to read. And for AWS, much easier, but you're still retaining a similar format to what you had seen in the Azure version, where it just says a resource and it's an object called an S3 bucket. That's a type, the name, and the actual credentials, as in the parameters that you want to pass through. Now, if we're using Terraform, this is how you create the exact same S3 bucket. You're creating a resource of AWS provider, and it's an S3 bucket and whatever name you want to give to it. That's the bucket name, and that's the ACL that we had just looked at a moment ago, public read. And lastly, this is the Azure version. So when you compare this against the default Azure ARM template, it goes from this massive JSON to quite straightforward, quite simple. The name, the resource group, where it's being deployed, tier, and basically the parameters. The benefit that you can see right now is going from Azure to AWS, it's almost identical syntax. There would be some differences in the parameters, like AWS calls it a bucket rather than a name, but it's much it's quite similar. So it's the same concept when you go to GCP or any other cloud provider. You learn this format once, you can apply it anywhere. All right, so that's the first quick introduction to IAC for deploying between those different cloud providers. Now, how we use Terraform beyond a single deployment. So this is the same storage account. Just a note for those of you that know Azure and storage accounts, this wouldn't actually work because Azure doesn't allow dashes. But just to make it easier to look at, this is how we would deploy the exact same storage account that I had showed you a moment ago in here, TF demo storage, but we're just putting variables in there that makes it more reusable. So you have TF demo, var environment, so it could be dev or it could be prod, and the cloud location, that's purely because if we're wanting to do a multi-region deployment, you can't have the exact same name. So I'm just going to show you what my variables file is. So here, you've got a dev variable file and a prod variable file. So this lets you set different flags like environment dev, which is being used here. It does a substitution, and multi-region true or false account here. So you could go in the prod environment, for instance, you could have a premium tier with a geo-redundant storage rather than a locally redundant storage. So it's just more things that you can configure in the variable files that get substituted in here. Location would always be the same for location 1 and location 2 if you're doing a multi-region. So I have to just take a step back. The reason why we're doing this storage account demo and demo backup, having this template done this way, it allows you to create a second region if specified, which is what we had seen by this multi-region flag. So by default, if it's false, this is just your standard ternary operator. If cloud multi-region is set to false, like in dev, what it then does is say count equals 0, so it doesn't bother creating a second region. But in the instance of prod, it'll just create region 1 and region 2. So this is how this exact same code. Yep.
And how about we talk a little bit about the difference between count and for each? Some of the differences we see when we use both of them.
Yep. So count, what this does is you can create multiple instances of the exact same thing, which in our experience, we've mostly just been using count as a 1 or 0 type scenario, whereas if we did a for each, let's just say for each, and you could do, say, environment. So if we did a list of environments here, dev, prod, and you did something of that sort. For each actually prefers an object rather than a list, but for the sake of discussion, let's just use this for each dev or prod. Instead of var environment here, you can go each dot value and each dot value again here. What that then does is it creates, for each item in that list, it'll create one storage account and replaces this with tfdemo dev and tfdemo prod. So that's kind of how we could use for each in this instance.
And one thing to note is that you can't use them both at the same time.
Correct. It's either one or the other. And for more advanced topics, what we've encountered, and it's a better way to use for each, is instead of using a list, we found that using it as an object, it's easier, it's cleaner, and you can label stuff as, like, say, dev, and then you actually put in the value here. And just replicate this downwards. So def prod. And another main difference between count and for each, if you're trying to refer to this storage account using the count, it would just go as a list. So you would just refer to this as Azure RM storage account dot tf demo backup, and you would have to refer it to item 0 if it was a count. But if it was for each rather than count, you refer to that as the key, which is dev. That's how you would just refer to the exact resource differently when you're using a count against a for each. So
and Ben, we just had a comment, nothing better than dynamic resource in Terraform from Shanky.
Correct. Dynamic resources are very handy. And this is the next step beyond in variables is how we can go from a bare minimum variable declaration, like in this case, variable, nothing in there. You add a description in there. You add a type to really enforce it. So you can't, for example, if it's a type number, you will always need to pass in an integer rather than a string. And this is the next step beyond where you have a variable declaration with input validation. So this example being for Azure, it expects Australia Southeast and not Australia, like your normal spelling. If you did Australia Southeast like that, it would error on you. So this is how input validation is quite handy. You're sure that when someone passes you something that would not get accepted by the cloud provider, it's just going to error on you before it even gets sent.
And Ben, have you ever had a situation where you've been too fancy with validation and too strict that it actually caused a problem?
Yeah. So this type object thing, it's something that you use quite sparingly, because at the moment, if you had a name and alias, and let's just say, just using the example here, common auto TFRs. So if it was something that was strictly typed like this, name and alias, and you added a third option here, let's say description equals main region, just for the sake of discussion. Having it strictly typed like this, it means that whatever that isn't specified, like name and alias, description would just get completely ignored. So if you try to do cloud location 2.description, it will actually error on you and it can't find it and returns a null. So use it sparingly it's only for certain situations that you would use it, and you don't want to go overly prescriptive. In some scenarios, it might actually be more convenient to just go map of a string. And it does the same job. You still can only pass in an object or map with the type of just strings inside there. So if you had, for whatever reason in here, put in an array of something of that sort, it would actually come up with an error saying that this alias is not of type string, and it would raise an alarm or flag.
Guess,
so that's what we've got.
When you're starting off in early development phases, you don't even need a type. You could just leave that out until it might change over time. So yeah, and then get fancier as you go more production ready.
Correct. So you start off with bare minimum and eventually go down. For the most part, we found that at this level, type string, it does most of what you would need. Guess the next level of having the validation in there is a good addition. So in this case, say if we had that, and you only want it to be standard or premium. Something like this would work really well. It's once you start doing validation on object types that it gets quite tricky. So to a certain extent, it's more trouble than it's worth, actually. But when it's simple things like that, you know exactly what values you're supposed to take in. Validation works very well. Do we have any further questions from anyone?
Questions right now?
Yep, all good. All right, I'll just don't save these, just close these out. So that is basically the summary on how we use Terraform beyond a single deployment. I didn't talk about the common auto TFR. So when you're creating one of these deployments, the code that you would use is something along the lines of Terraform plan, or you pass in a var file of sample2 deployment, and you pass in the dev.tfr. So this way it's only loading the dev and not the prods variables. But when you have a file that ends in .auto.tfrs, it'll be common and it'll be loaded in alongside the dev and prod. So this is handy for stuff that's consistent across all your environments. And like in this case, Cloud Location 1 and Cloud Location 2, that's consistent regardless whether you're in dev or prod or UAT staging. So this is where you make use of not repeating yourself too much. Like in this case, account tier and replication type, that's potentially something that's environment specific. So you would put it in your environment TFRs. But other things like, say, if you had your, I don't know, like your key vault number of days for retention, if it's always going to be 30 days, 60 days, 90, you can put it into this common TFRs.
And then there's one more step to the hierarchy as well of environment variables that Terraform will pick up as well.
So when you have a variable in here, like say if we declared another variable of demo type string, if you created a variable of this sort and that the value of this demo variable isn't found inside either dev or prod or any of the TFRs, it will actually prompt you when you try and run a Terraform plan and say, what is the value of variable demo? Now you can either put that value inside one of those TFRs, or the other option is, I'm just going to use a Linux one because that's easier. All right, so you can do something along the lines of this: export tf_var_. It's very specific, the naming, it's tf_var_, and then the name of this like in this case, demo equals var, something along those lines. So that way, this tf_var is on the lowest level hierarchy. So it reads files in a certain way when you've got something that's in, say, for example, in this case, if you had environment equals dev in here, and if we did the exact same thing, tf_var_environment equals demo. So now what has happened is that we're assigning the environment variable with 3 values, one in tf_var, one in common auto TFRs, and once again in a prod.tfrs. So there's a layer of specificity to it. It takes, if something is specified in prod in a specific TFRs, that's the highest priority, followed by the auto TFRs, and lastly the tf_var_environment variable. Now the very top of the specificity is when you pass in a variable in here. This is something that I don't do often because it's probably not good practice. I believe the syntax is something like this: var environment equals staging, something like that. This is the top tier, the nuclear option, I suppose. Whatever you specify here, that overrides everything else. But for obvious reasons, you probably don't want to be specifying all your variables or any variables in the CLI, because that's just not source control. So that's, I suppose, chapter 2, how we use Terraform beyond a single deployment. Now, moving on to modules. This is something that we use very often in Mula right now, because modules are great. You create a set of code that is repeatedly applied across all your projects or your separate repos. And how that works is, let's just take an Azure function app as an example. So if you wanted to create a function app, you could have a lot of parts involved. So the bare minimum to create a function app is that in Azure is an app service plan that hosts the function app, followed by the function app itself. Now, if you wanted to have logging enabled, you would also create an application insights resource. So that this is already three items in here. And what about if you needed staging slots for your function app? Then you go around and add a fourth item in there. So as you can see, this file is getting pretty long. We've already got 4 resources in here, and it's just slowly getting bigger and bulkier. Now, using modules, we can consolidate all of these into one item here. So just module function app primary, you pass in those variables, and then it goes away and creates all those things, which we can see in the screenshot here. If you ran that module function app primary, it's creating an app service plan, it's creating the function app, creates a function app slot, and various other bits and pieces that we've just bolted together into the function app itself. And one of the main perks that we really like about using modules is that you can enforce certain standards that your company has decided to do. Like in our case, what we have done is we enforce the naming conventions of -FA for any function app, -ASP for the app service plan. So it's certain standards that you can enforce and sort of hard code in there. There are also other useful things, like in this case, we've hard coded that HTTPS only is enforced true. There's no way for you to manually override it and say, nope, I want to allow standard HTTP. It's already bolted in here. It's not going to change. So that's the benefit of using modules against straight up resources, as we can see in here. And now these modules, the way we build them, it's extendable. So what we have done is we created a bunch of these object configs. So what is your app insights config? What's your app service plan config? And that gets written into a variable file, which we'll see here. So function app application 1, the name of the function app is HashiCorp demo. And in this case, the app insights, is it required, true or false? So if this is flagged as false, let's just use the app service plan as the first example. If required is true, then in the module itself, here, that this flag itself goes true, and that means you create one count of the app service plan. Now, if we were to flip it to false, that way this app service plan doesn't get created, count 0. Down in here, we still need to pass in an app service plan ID to the function app for something to host it. So if the app service plan is required, it passes in the default ID that was created from this. Remember the square bracket 0 for anything that has a count on it. And if we chose to say app service plan is not required, then it's going to read from the variable in there, and you're supposed to pass in the existing ID of an app service plan that you want to use to host it. So this would, in Azure's terms, take the form of something along the lines like this: subscription and subscription ID. And this being, this is like some UUID thing. And then it'll go resource group. This is the name of the resource group. And so on and so forth. It's the actual ID that you pass in here. But in our case, because we are creating the app service plan, we can just leave that as null. And it will then pull from the app service plan that it needs a standard SKU of type S1, and it's a Linux app service plan, which all gets passed down to here. You'll see the SKU is ASP.config.SKU-tier, SKU size, and SKU kind. And there's also certain things that we can pass in here, like in the case of Azure, if it's a Linux app service plan, reserved must be set to true, otherwise it must be false. So there are things that you can use these kind of if-else ternary operator things to, well, avoid passing in unnecessary variables. So that's how we've been using modules. We actually have modules for almost every resource that we are deploying right now in Azure. And some of them are more complex, like we see here in this function app, where this one module creates multiple resources. Others can be a lot simpler, like in this case, in the case of a storage account. For the most part, all we're doing is hard coding it that the TLS must be 1.2, whereas the rest of it can be a variable. So even for a single resource thing, there are instances where you would want to make it a module just so you enforce certain standards, because if you don't, well, any dev that comes in, they may not put in that particular TLS version, and it will default to, could be 1.0, 1.1. It depends on when they update the providers. But in our case, we want certainty. We want it to always be that exact value. So that is how we've been using modules. Go back to here. Let's see if there's anything I missed. Function app, slots, app service, VNet integration. Yep, exact same stuff. So that's what I was talking about. You can use this same module because the main parts about these modules is it might take you some time to set it up in the first instance, but once it's done, you basically can just reuse this code again and again for every project, and it's consistent. Now, another part that I had not touched on earlier. So in this case, I'm using this module as a local module. Local being wherever my Terraform file sits, the module sits within the same repo itself. There are multiple ways that you can do this. This being a local module, another option is using Git. So it'll take the form of, let me just steal that code from somewhere. Give me one sec. It takes the form of something like this. Oops. So git ssh bitbucket, and this way, because you're retrieving it from a central Git repository, you're source controlling it, and you know that if that's a data factory, but if I wrote that as function app, whenever I update this specific function app in Git, any projects that reuse this module, you're always getting the latest, greatest version of this particular function. So down the track, if I added a new parameter in here, let's just say app settings. Let's see. Oh, let's just say if I wanted to, if the naming convention changes and function app no longer needs the suffix, if I just take that out and that gets committed, the next time you pull this, it will read the latest changes and update accordingly. That probably wasn't a good example because by changing the name, you're essentially deleting and recreating the resource, but you get the idea. So that's how we can use the source. Git being one option. Another option is HashiCorp's own Terraform registry, which I can't remember off the top of my head what the format is. Your private registry. So it's something along the lines of HashiCorp / name of the actual resource. So this isn't going to work because there's probably not that specific resource, but that's the format that it takes. The provider and the name of the actual module. So that's how you can use, well, 3 different or probably more different ways of referencing a source for modules. All right, so moving beyond modules, this is a part.
To that,
yep.
Sorry, to that, you can actually have the branch in the Git as well, so you can have like release branches.
Yes.
And one thing that we probably want to improve on in the future is that we had all of our modules in one Git repo. So as we started off, we had a lot of our modules are actually like for the resource. So we actually improved on that over time, and we added more resources to the modules. So it wasn't just just sort of defeating the purpose. And then HashiCorp sort of, they almost recommend that you have each module is in a different repo, because then you have that's probably where we want to end up as well, right? So
Correct.
because we're using the open source version, when you download the modules, it will, you normally don't go into it, but you have a .terraform file with your modules, and then each folder will be replicated over and over again, if that makes sense. But yeah, I guess that's one thing we did learn. Yeah. Mm-hmm. And then also you can do like your branch. Yeah, exactly.
Or
so
something along the lines of this.
Yeah, and if you use private, if you use Terraform Cloud or the enterprise one, which is pretty much the same, you can manage that source control better. But yeah, I guess that's our next step, is that we'll probably break down bigger modules into their own repo as well. So it's more poly repo instead of mono.
Mm-hmm. All right, so moving on to the last item. Don't need any of that. Go away, go away. All right, so this is probably the most exciting part for us, where after we've already created all these Terraform codes, how do we get it to be auto-deployed? Because we don't want to be sitting here all day and running Terraform plan, Terraform applied, those steps. So what we had done is we've created, in this case, again, this because our Mula being a Azure shop, we're using Azure Pipelines to do these things, but essentially you're going to be able to use the same steps to run it in GitHub or any of your Git repos. So this is the pipelines. I'll just show you what it actually does first. It creates something along the lines of this. So it does your Terraform plan for your multiple environments, like dev and prod that I had shown earlier. It plans it all out, and it runs checks and determines whether it's supposed to be a simple automated thing where it just automatically approves itself, or if it requires a developer to cross-check it, where say for instance you're deleting a resource, that's something that you would definitely want a manual check over to be able to be sure that that's actually what you want to execute, and not a dev accidentally commenting something out and causing something to be destroyed. So the two checks that we're currently doing is Open Policy Agent, OPA, and Tfsec. I'll start with Tfsec. This Tfsec itself is a static code analysis, a scanner that runs through your code, and what it does is it reads through your code and checks against known vulnerabilities. Like for instance, is your key vault open to the world? Is your storage account open to the world? Now it would put forward recommendations saying you should have some form of access control language in there that says, no, I only want to allow IPs from this certain range or from this virtual network or VPC. So these are ways that Tfsec, it just looks through your code and gives you recommendations to say that how can you improve on the security of your apps, because by default, if you just run with your standard vendor specifications, there are improvements that can be made. And the next part is Open Policy Agent. I like that graphics, it's very cute. Open Policy Agent is a user-defined guardrails of sorts that I'll show you what we have in the policy.rego. So what this thing does is you specify what resources you want Open Policy Agent to check against. And what we had done in the company was we separated them into 3 different categories. One being critical resources, important, and low risk. Now, these are all completely arbitrary numbers. We have just defined a score of 2. So critical resources, like in our case, SQL databases, service bus, so messaging, anything that has to do with stateful applications, we set that any kind of modifications that are done to it, this is a score that we've done, anything critical. If there's any deletions or any modifications, you're instantly over the maximum acceptable score range, and it'll say, no, you require a human to cross-check this to make sure that this is actually what you want to do. Now, this 99, we've just put 99 because that's a big, scary number. This max acceptable score, again, it could be anything. We could say that I only want a score of 1 or a score of 10. So this would be a case-by-case basis that your company would try and see what works best for you. In our case, we went with 2. So what that means is, in these important resources, if you modify one of them, sure, it seems like it's probably a change that you wanted to do anyway. If you modify 2 of them, still probably okay. But if more than that, it's probably a sign that you would want someone to cross-check it and make sure it's doing what it's supposed to. Whereas when it comes to the low-risk thing, you can modify as many of them as you want. We've set the score to 0, but if you start deleting them, we're using the same rule again. You delete one of them, probably intentional. Deleting 2 of them, potentially there's something that you need to, again, cross-check. So that is how we are using OPA to scan through our Terraform plan and then give us an automated score of should this pass or should this fail. So using these two, OPA and Tfsec, it checks, makes sure that our Terraform code, firstly, it passes the Tfsec. We're not introducing critical vulnerabilities in our code. And secondly, is it doing what it's supposed to do? Is it deleting any resources? Once it passes both of them, then we give it gives you a warning like this: plan passed validation, safe to proceed automatically, or plan did not pass, requires manual approval. And then you get this automated pipeline process, which works pretty well for us. And the best part about this is it's completely scalable. Right now, we're running it through a container. So that container checks OPA and Tfsec, but down the road, if we wanted to add extra checks in place, one of the candidates that we're considering is a cost analysis thing. So if we're planning to do something along the lines of, if your monthly bill is going to be, 10% higher or 30% higher, that might raise a warning flag and say that this requires manual approval because you're incurring significantly more costs than we had before. So this aspect of it is completely scalable. You can just do more or less checks, I suppose. So I'm just going to show how this works. So triggers on PR, we've got variables and stages. These are the things that it's going through. So say in the test environment, you plan, and based on the outputs of that plan, it gives you one of those things, whether it passes or fails. And if it passes, you can automatically apply. If it fails, you go through the manual step. And how this works is we've got these conditions. Come on. So it checks, did the previous step, which is Terraform plan test, did it succeed? If it did, does the output of auto approve, is the output true? If it is, then it goes through this, otherwise it skips it. And for the manual step, it's the same thing. It succeeded and auto approve is false. That way, you're either going through test or as an auto or manual approval for these steps. And all we're doing in these scripts is actually just running through a couple of these steps, which I should just open all of them. So the step itself, plan, gets an SSH key, runs Terraform init, plan, validate, and then uploads it. So these are the scripts that we're doing. Step 1, Terraform download, relatively straightforward because these build agents are, well, they're ephemeral. They don't have all the binaries involved. So we install Terraform into the build agent, initialize Terraform. We send them to, because we're storing our state files in a remote container, we put them in either a prod container or a non-prod container, and it just sends it to the appropriate container. Once it's retrieved the state file, then we run Terraform plan, outputs a TF plan file. Then we take that TF plan and we send it through to our validation check. So in this case, we're getting the plan validator check our plan. And in this case, because it's an Azure, we've built this validator in a way that it's able to scan plans for Azure, for GCP, for AWS. What we're doing here is we're just specifying Azure so it knows which policies to check against. And then it just tells it, did it pass or did it fail? So this validation check, it contains more logs about what exactly is happening. We can see what happened in there, but all we care about for the automated pipeline side of things, that's just for debugging purposes. You can look back and see what happened. It'll just tell you, did the validation pass, true or fail, true or false. If validation pass, auto approve is true. Otherwise, auto approve is false. And then you clean up after yourself, getting rid of the JSON plan. And last step, just apply. You just get a plan, Terraform apply, off you go. And it just does either the auto or the manual approve stage. So let's see if there's anything I didn't cover.
And
just gate checks.
Just talking about that as well. If there's any companies that want to adopt what we've done with validation, that we've open sourced that piece of the work, so we're more than happy to help you adopt, safer practices with Terraform as well. So please reach out to us if you need help with that. We're more than happy to help you.
Mm-hmm. And there you go. That's in summary, how we got it to deploy via the pipelines using. I've got a laggy mouse. We're using this pipeline script. It looks a bit scary when it's this long, but generally it's the same thing. Just repeat it. You've got apply, you've got plan, and it's just auto approve or manual approve. So,
and the reason we do bash script as well is that if we tomorrow we have this in Bitbucket as well, but if you want to go to GitHub or anything, it will pretty much plug and play, and then you're away.
Mm-hmm.
A little bit different syntax, or orchestration of the scripts, I would say.
Yeah, those would just be consistent regardless of which build agent you run it on. You would just change this pipeline aspect of it to be GitHub specific, Bitbucket specific. But for the most part, this is what it needs to work, and it's been working pretty well for us thus far. I guess that's the end of the pipeline talk. So I'm happy to take any questions if there are any, or any comments.
What about while we wait for some questions to come through, do you have any war stories to share? Things that when you started off, things that you would do different, or hiccups that you had along the way?
Man, I think the thing that stumbled me the most was this pipeline deployment, because this particular step, there's just so much involved, and you can just see that amount of code that's involved in it. It's one of those where once you get it right, don't look at it ever again until something is broken. So just don't fix what's not broken. This one was good. And modules wise, that was a bit that I was talking about before, where we had in some cases gone like this. This is exactly what I was talking about, where we had strict typing on the function app config. So let me just open this alongside the variables file. We tried to be overly prescriptive with this about what exactly can or cannot be in there, and it just caused a lot of issues. So there you go, strict typing caused issue with IP allow lists, and it just broke it, and to the point that we just decided, you know what, we don't need to strictly type it. Our validation will just catch the things that are relevant to us. Like in this case, we just want to make sure that they're passing in an acceptable value of what Azure can accept. It's either .NET, isolated, Java, Node, the list in here. So if it passes this, we will let Azure warn us if anything is incompatible, rather than us being trying to be too smart in here.
Yep, and just got a question I'll answer from Shanky. So thanks for the question, by the way. So can you set conditions like if you try and delete a critical component, you will need to approve manually with Terraform with OPA? So the answer is yes, you can. So Ben, can you just quickly bring up that policy again?
Yep.
So we've defined what we think is critical resources. Like you can change this as well. Like I mean, you can have anything a critical resource if you want. So to us, critical resources are like, are you gonna there's create, delete, modify. So let's say if you're gonna drop a database, that's pretty critical to us, and we want to know about it. So how the tool that we made, what it does is essentially it will say, does this match my policy? And it's in OPA and Tfsec. So we've sort of like glued both of those together in a Golang script. So first of all, it will go for OPA and say, okay, let's analyze this Terraform plan. Are you trying to delete, or modify a critical resource? If you are, then it will return 1, true or false. So it's does this validation pass? And if you say false, then that will in the pipeline that will go to the manual approval process, like in Ben's picture. So that will say, okay, you didn't pass. There must be a very good reason for you to be deploying this, but we don't want to block the business value in that pipeline from releasing. So if the developer, in some cases they will need to do that. So therefore they are allowed to do it manually, based on, some compliance wrapped around that process wise. So yeah, you absolutely can do, it will stop it and put it to the gate. And we've seen that working very well. So we have defined 3 severity levels as well. So we have, and these are both relating to OPA and Tfsec. So it's low, medium, or high
Critical.
risk, and critical as well. Sorry. Yeah. So what you can do is you can say, I can set my tolerance to, we generally just do critical. So if you have a critical security vulnerability or your policy is critical, then you won't pass. But you can actually do medium as well. So you can be more like paranoid about auto approve. So you could even go to low, and low can be silly things like
Not using the latest version of an app.
a framework. Yeah, like of .NET Core or Python or whatever language you use. So yeah, so you can change it to this very level, and it works very well. It's like a proper guardrail that probably a lot of businesses don't actually end up implementing. But yeah, if you want to learn more about it, reach out to us, and I'll share the Git repo with you as well, and that will give you a little bit. I'll update the README and I'll give you a little bit of understanding about that. So yeah, thanks for the question.
So this is the manual validation step that it will notify whoever that we nominate as the contact person, and it just sends them an email of this particular pipeline requires manual approval. Please review the output. There are further guardrails that we can put in place. Right now, we have just enabled it that any developer that has access to that pipeline can approve it. You can always tweak it to be even more strict, saying only the team leads or whoever is within this specific group are allowed to approve it. So that's more ways that you can further fine-tune this critical resource check. And the important thing is, because this is server, it doesn't actually hold up your VM. It doesn't hold up the build agent from running other tasks. This is just like a pause that doesn't block other builds from happening.
Yeah.
Did you have something to add, Brad?
Yeah, I was just going to say, I'll just share the repo in the chat as well. Mm-hmm. Shanky, if you want to maybe take a screenshot. So we call it the Terraform Plan Validator, where we use that in production at the moment. I probably, because we wrote it, we know more about it, but I might update the README for you as well. And please reach out if you need some help with the pipelines as well.
Mm-hmm. That aside, let me think if there were any other pitfalls that were related to that specific question. So again, this critical thing, like I was mentioning before, it's all completely case by case, up to you in your company or how you want to do it. You may decide that, I don't know, if app service is a business critical thing for you, you might decide that that's not in the low risk. It might be an important resources thing, or you don't even need to conform to how we've written it, where it's these three categories. You could do something along the lines of individually scoring things, like in this case, the app service. You could say that app services are of, I don't know, 1 in delete, 1 in create. So you cannot create 5 app services in one go, for example. But this is completely user defined, is what I would call it. And there are another thing to consider is that these resources, if you don't list them in here, like say we don't have container registry, I don't believe it's in here. So yeah, it is.
Important resources. Yeah.
So if you had something that, I don't know, like say Azure RM machine learning suite or something along the lines, if you don't list them in one of these resource types, then it won't consider them. So for example, if you thought that storage containers are not something that's important, or log analytics, if you don't need them, don't put them in there. You can add or delete 100 of them and it's not going to care. So it's purely user specified, which is good and bad in its way. You have full control over how you want this to pass or fail your scan, I suppose.
And yeah, like this tool will work with GCP, AWS, anything that you can put well, you can actually put anything under OPA policy. But what about one thing I don't actually know, Ben, is let's take an example for function app, for example. Can you go more granular and say the function app with this name? Because that could be like a business critical. I haven't actually done that before.
Yeah, but if not, I don't know if this goes to that level of granularity, because it all depends on what the score thing is doing.
Yeah.
So these portions down here, this score thing, this came straight out of OPA's doc. So we didn't write these functions. So they've done stuff like this, not touches IAM, this being a method or a function, you could call it. So
yeah.
This itself says if there's any resources that's of AWS IAM type, if it's more than one, it's going to straight up fail you regardless of what your score is. So you could always do different things, whether it's resources or other calls.
Yeah.
We had not investigated into that. Yeah, this one's completely unrelated to us.
Yeah. But yeah, you can, like, I guess to answer my own question, you can absolutely do anything on OPA. You just have to sort of code it.
Correct.
Which is not that hard.
So this is exactly how it's all written in here, how it's doing the resources, how it's actually getting the scores. So there's no magic under the covers. They're all actually written down in here that you're free to update, change however you like. And it's just all listed in here. So
and it looks scary, but to be honest, we didn't really look at it too much. Like, it just worked out of the box, so we were super happy with it.
Correct. The only thing we actually looked at or configured was these. So the weights and the resource types, those are I guess including the score. So that's all we actually modified. The rest of it down here, out of the box. For something that's out of the box, it does it surprisingly well. There was no glitches whatsoever.
Yeah, that was awesome.
And
yeah. All right. So yeah, thanks everyone for coming. Yeah, like I said before, if anyone wants to do a talk here, you're more than welcome to. Really looking forward to in person again as well. There's also a Melbourne chapter of this too, so make sure you check that out as well. And then, yeah, thanks very much, Ben, for giving us the demo. It was really cool, and I hope some people got some stuff out of it.
Thank you all for coming. Hope this was an instructive session.
All right, thanks everybody. See you next time.